Okay, so for this problem we're going to try to find the largest moment that can be exerted here at this slice point at C. We've got this strange kind of tractor-trailer combination of 4 loads, 2 meters, 1 meter, and 1.5 meters, and you can see the various values. And it can move in either direction. So what's the first step? Draw the influence line for the moment at C. So I'll have I'll put a template down here. So I'm looking for the moment at C. And I'll kind of just transfer some basic ideas here. Now remember, the way we kind of visualize this influence line to get the shape using the Mueller-Breslau principle is we kind of come to C and we imagine a hinge. Since we're doing moment, we kind of take the moment capacity away, and then we look at positive bending moment applied to both segments. So this point C, under this kind of loading, would it move up or down? It would probably move up. So as this point goes up, and it's still attached at the supports, then the basic shape of the influence line looks something like that. And again, this would be the dimensions of 10 meters and 5 meters. So the way we've been working these problems, the way I can find the value of the influence line here is to go back and work this problem with my moving unit load being where? Probably here at C, and then I want to find the internal moment at C. So to find that value, the case that I would be looking at would look something like this. I've got a roller at the left side and a hinge connection or a pin connection at the right side, and then there at C I would have the unit load, and that's at 10 meters and 5 meters. So to find the internal moment at C, I would probably want to cut it there, and then I'd either work the left side or the right side. Which one do you guys want to work?
Right.
Right. So that means I need to then cut the structure on the right side. I would need to find this reaction at By, and then I would want to then compute the moment at C. And my unit load would still be sitting right there. And that has the dimensions of 5 meters. So that's kind of what I need to do. So to accomplish that, I need to come back up here and find my reaction at By. And of course, there would be a similar vertical reaction over here at A, but I'm not really concerned about that one. So what's the easiest way to find my By reaction for this case? Some moments at A, right? So I'll come down here and using right-hand rule for my sign convention, I'll sum moments at A. And when I do that, my unit load, my moving load at this position creates positive or negative moment. Negative, so I'll have -1. It has a moment arm of 10 meters, and then By creates positive moment times 15. So what's By? Looks like it's 2/3, or 10 divided by 15, right? So now that I know that, I can now sum moments again with right-hand rule as my sign convention at that point C. Make sure it's in equilibrium. So now looking at this free body, the internal moment, positive bending moment with my sign convention is negative. And then By creates positive moment. By is 2/3 and has a moment arm of 5 meters. So it looks like the moment at C is 10/3 meters. So this will have the units of meters, and this will have a value of 10/3. Okay? Mr. McBride, any question? So there's kind of like the first part of the problem. I now have an influence line for the moment at C, and now I need to let this truck move from left to right and right to left. So let's think about this for a second. Let's say it's moving from left to right. So it's coming this way, and as all the values hit here, as you look back to the left, what's the slope of this side? So what's the slope, say on this on the left side? What's it going to be? So it's going to be rise 10/3 divided by 10, which is what? That's 10/30ths, right? Or what? 1/3? Is that right? Is that right? Yeah, 1/3, right? What about on this side? On the right side, it still has a height of 10/3, but now the run is only 5. So what's that? 2/3, right? So as you see, as you move 1 meter to the right, the value is going to be higher than 1 meter on this side. You see that? It's dropping off faster on the right-hand side than it is on the left-hand side. So when more of your forces are on the left-hand side, they'll probably have higher ordinate values than on the right-hand side. You see that? So probably then the best direction that would create the largest value would be the truck going from left to right, because most of the forces would be on this side. If it turns around and goes this way, then what happens? Well, most of the forces are going to end up have smaller values. That's one way to look at it. So let's check it from left to right first. So let me. That's not a hard influence line to remember. So I'll just flip that up out of the way. And we'll check the first case. So we're still looking for the max C, say for case 1. So here's what my influence line looks like. So let's see, the first load that comes onto the structure is, I'm going to have to flip back, sorry. So I've got 4, 6, 2, and 1. So the first one that will come on will be at 4. Right? And then 2 meters back is 6. Sorry for having to flip back and forth. And then 1 meter back is 2. And then 1.5 meters back is 1. Did I get all those right? And those distances are 2, 1, and 1.5. So this is 2, 1, and 1.5. And we know the slope on this left-hand side. We already computed that once before. Let's do it again. The slope on this side, the max is 10/3, and then the distance is 10. So the slope is 1/3. So every meter I go back, I drop 1/3. Now this high value here is 10/3. So 2 meters back would be what? This would be 8/3. Another meter back, 7/3. Oh, 1.5 meters. That's going to be bad. So that would be 5.5 thirds, right? Oddly enough. Do you see that? You get all those values, and then it's just a matter of adding them up. So in this case, it would be 4 kilonewtons times 10 thirds meters plus 6 kilonewtons times 8 thirds meters plus 2 kilonewtons times 7 thirds meters. All right, hang in there, we're almost done. And then 1 kilonewton times 5.5 thirds meters. So what's that all equal to? Somebody calculate that. And while you're doing that, I'll check the second case, or start the second case. So again, I'll resketch the influence line. For the moment. Anybody get a number for this? Nobody?
I got 35.8.
35.8? Okay, cool. So that'd be 35.8, and that's going to be kilonewton meters. So now we're going to let the 6 kilonewton force go to the top. And then 2 meters in the front is the 4 kilonewton force. 1 meter behind, 2 kilonewtons. 1.5 meters behind, 1 kilonewton. My spacing got a little big there. It's not to scale, as you can see. So I know this value is 10 thirds. 1 meter back will be 9 thirds. 1.5 meters back will be 7.5 thirds. And the slope on this side is twice as big, or 2 thirds. So when I move 2 meters over, I'm going to drop 4 thirds. So this should be down to 6 thirds. And then I can calculate the second case. So now I have my 4 kilonewtons times 6 thirds plus 6 kilonewtons times 10 thirds meters. I left the unit out here, it's meters. Plus 2 kilonewtons times 9 thirds meters. Plus 1 kilonewton times 7.5 thirds meters. What's that?
36.5.
Oh, it's better. 36.5? Anybody else get that? Yep. No? Yeah.
I don't know. How did you get 6 thirds going from 10 thirds to the right?
The slope on this side is 2 thirds. So I move 2 meters, I drop 2 thirds twice. So that'd be 4 thirds. So 6 thirds minus 4 thirds is 6 thirds. I mean, 10 thirds minus 4 thirds is 6 thirds.
Oh, you do 2 of them.
There's 2 meters here.
Okay.
So I go 2 times the slope is, you drop 2 thirds for every 1 meter, so that means 2 meters you drop 4 thirds. Wow, we run out of time, and I'm only I'm only 2/8 of the way through the problem. Bummer. I think you see the idea, though. What would case 3 be? Well, I'm halfway through the product. Thank you, Mrs. Rowan. So I would let the number 2 guy go to the top of the hill, and then these 2 guys would drop down, and then I have to do one more. Now, when you do the last case, I think all your big loads are way down here on the bottom and have very low ordinate values, so that probably will not be the maximum value. So right now, this looks like the best case. I'd have to check 2 more cases to be sure. What I'll do is I'll go ahead and do these in the office after class, and I'll publish this on the PDF version, but obviously the video will stop right there. But you can just continue this 2 more times. Oh, and I should probably say that this is probably a little too much to ask for the exam, just because it's too many cases to check. The idea is the same. In fact, I would say that this is a reasonable influence line you have to draw, something like this. Maybe not check 4 cases, maybe 2 or 3, maybe one direction. Maybe more similar to the previous one. So any one of those would be a reasonable problem. Okay.